Good. So second part, design by feature. You're covering the book, textbook, and chapter 8. Right? See, can you see my face?
Yes.
All right. This is a house rented by 6 visitors, including Youngi. We are using Airbnb rental system. Can you hear the sound noise?
No.
No? The house is just beside the tram system. Not subway, is a overway, a train. So the noise is very high here. And here's in Chicago. Time is 11, almost midnight. But it's better than before because of the summertime is changed, stopped. Right, let's go ahead. So I will cover procedural technique and declarative technique. Which one is already covered by Tyler at the beginning, the concept. So general purpose programming language. And then procedural method is defined by general purpose programming languages. And there can be another special purpose feature definition languages. If you use your own special, say, commercial CAD system, usually provide such special purpose languages only for their CAD system. But nowadays, they also based on general purpose language, something like a Python. But they customize that Python language only for their product. So in that case, we call this is a special purpose customized language, you can say. So procedural approach, there is generic features and also distinctive characteristics and also declarative technique together. So procedure and declarative is different, right? So procedure here, the timeline, the history, the sequence is important, right? Instead, whereas the declarative, there is no importance on sequence or time history. It is only important is a set of declaration, or you can say a constraint, set of constraint. Is it enough? It is over constraint. That is important, but sequence is not important. So once the proper set of a good set of constraint or declaration is given, you can solve that constraint together or together at once to arrive at the conclusion. That is the way. But the procedural one we are doing in commercial case system using modeling menus or command. We modify one by one along the modeling history. All right. So there is 5 processes of modeling or features. So we can develop an overall model and feature list, and then we can say design by feature or build by features. The construction phase and startup phase can be separated in declarative types. And for the procedural features definition, you can use any language, and HUT-CAPP is process planning, CAPP, specialized and developed in Finland University. Right? So they say this is a kind of feature modeler. It is a modeler developed for feature modeling. You can say the Transcad is similar situation that it is specialized for translation. And here, HUT-CAPP can be seen as a specialized modeler for process planning. And in Finland, they use a general purpose language called LISP. There is a general purpose language for used for artificial intelligence programming. And in Finland, they use for LISP as a feature definition language. And there is also interface to C common language. And they call this is a geometric modeling system. So you can say this is a special purpose feature modeler specialized in for the CAPP. And LISP is a general purpose artificial intelligence language for with object-oriented frames and allows access to solid modeler, something like similar to your access to the open cascade. Because solid modeler or geometric modeling is corner. Right, next slide. This is a picture shows procedural feature definition at HUT-CAPP system. So they start from a block. And can you see my screen then?
Yes.
All right, let's continue. It has a shutdown. Anyway, so we are talking about HUT-CAPP, feature hierarchy, and the feature model is regenerated with the model. And the programming language usually has a problem of modularity. Express language is a special language only for developed for ISO step standard that has a procedural feature definition language. And there is another one is impact modeler. They also use another specialized language called part design graph language. So there has been several different thread of development. Okay. So on the line is a PDGL explanation. This is also for process planning study groups. And right hand side, you see some explanation and sample of impact definition of stepped hole features. Okay. And Arizona State University, they also have a feature testbed. They have a feature library and operational sequence. And there is also, they provide the validation rules and also language parsers. So the several candidates, including Finland HUT and also ASU in Arizona State, also Step Express. They are doing similar approaches. Right, the declarative technique, once again, it is the sequence of history is not important. The importance goes to the complete set of constraint definitions. So you can say constraint-based feature definition. And finally, the satisfaction, solving the constraint equations, we arrive at the wanted model at once. So declarative approach is a non-procedural model. As I say, the sequence or timeline is not important. And then we have a set of declarations or constraint. So we are saying that it is separating definition, feature definition separate from implementation. So separation is explained that geometry and other properties is in neutral form. They have a CSG and BREP2, and then the declarative modeling is done by constraint. So constraint is most important in declarative schemes. So how can you constraint is specified? It's declared, and then finally when it's declared, enough complete set of constraint constraint satisfaction algorithm is used to solve all the system of equations. And between them, there is dependencies sometimes, because each constraint can have dependencies and composition dependencies and intra-feature dependencies and other things. And also assembly dependencies. There is a mating condition between parts. So that kind of thing can be considered. Say, in mathematical form, each equation has independent or sometimes can be dependent each other. So they are saying in this way. And here you see that it's constraint set specification. So we have a similar constraint set, very similar to feature set or menu set, you can say. So operational and positional menus looks like a menu, but each one is used for defining or specifying constraint. Very similar to feature comment. And constraint for coordinate system is also similar to them, and there is also orientational constraint too. So it is similar, not special to constraint. And figure shows the coplanar constraint thing. So it looks like a parallel positioning, or underbody. Figure 8.9 shows a coaxial constraint set. And this picture shows position constraint examples. So there are a set of constraints defined in ISO standard. And then, so we arrive at definition, a set of constraint. So we can say this is a combination of constraint. And then we can draw a graph based on a set of constraint. So graph can be, generally, we are saying there is a node and links in any graphs. But here, the graph is specialized to represent constraints. So that links is used for representing constraint, and node is used for any geometric entities. So we can arrive at the bottom figure shows left-hand side is step door on block. So the geometry is given here. So based on this geometry, we can create right-hand side. There is a constraint graph. Right? There is an example. And then we need to solve that constraint system. So we call this is constraint satisfaction. We start from a set of geometric constraints. Algorithm is also classified into 4 different categories. One is sequential. You should not confuse with the previous discussion on sequential and numerical system. No, sequential and procedural and what was that? Declarative, right? But this one is a different one. This is only for satisfaction algorithm. There is a sequential satisfaction, numerical satisfaction, and symbolic satisfaction, and truth maintenance. All right, and then there is a explanation on what is the sequential constraint satisfaction. There is a well-known Serrano's method. They use graph and statistic matching. And there is also delta blue method example as a multigraph. And then it has a strength attributes and coupled constraint and inequality. So delta blue method is explained in figure 8.16. And this one shows another one called Constraint coming from Mantilla from Finland. So they use another way of constraint satisfaction method. And the brick problem is explained as examples, but I will not explain on the details here. And then numerical constraint satisfaction, the second category. So under body, you can see the picture figure 8.19. It is shown as a dynamic system with a spring constraint. Anyway, you need to have a system of equations or system of constraint. And then there is some issues, something like initial guess and multiple under constraint system. And then other categories like a symbolic constraint satisfaction method or truth maintenance categories. All right, that's it for me. Do you have any questions on this?